Good morning, everyone, or good day if you're watching this online. I'm Lydia Hallie, and I don't have much time here, so let's just get right into it. What is new in React 19? Now, I know that many of you sitting here today have used frameworks that already had React Canary bundled, so not all of these features will be really new to many of you, but there are many that are now stable in React 19. So the first one is that in React 19, we can now pass asynchronous functions to start transition. So transitions were introduced in React 18 as a way to mark a certain state update as non-urgent. And we can do this by wrapping this update in a start transition. So by default, React renders all the necessary components in a single, uninterruptible task. But depending on the complexity of this update, it can take quite a while before React has actually rendered these updates and then committed them to the DOM. And since this is all happening on the main thread, our application is unable to handle any other tasks during this time, which leaves the UI unresponsive. So if a user interacted with our website while React was rendering an update, they would experience quite some visual feedback delay. So transitions provide a solution to this, because instead of rendering the update as a single, uninterruptible task, React will yield back to the main thread every 5 milliseconds to see if there are other tasks waiting to be handled instead. For example, that user interaction. Because if that's the case, React will pause the current render, let the browser handle the task, and then eventually get back to rendering. And it only commits these updates at the most performant time. So transitions ensure that the UI stays responsive during an update. Now, it's very common to have a scenario like the following, where a user can submit some input based on form data. So within the submit handler, we first manually set is pending to true. That causes React to re-render, showing the pending states. We then initiate the async task. Eventually, once that completes, we set pending to false, and then handle the data or error that gets returned. And this works, but a few things could be better. Let's say that we first update the data with the name Lydia. Now, if we rendered this to the UI, saying you successfully updated to the name Lydia or something, it could happen, or the following scenario could happen, which looks a bit visually overwhelming. But first, we update the name to Lydia. And while this submission is ongoing, we change the name to Evan. Now, finally, some data gets returned because our network request finishes. So now we set the data in the UI. So the state is now Lydia, but the user might have expected Evan because that was the latest submission. And that only happens after the second request return. So this could lead to some unpredictable, suboptimal user experience. And also, there's just quite a lot of boilerplate to handle data, pending, and error states. So in React 19, we can now refactor this to be a transition instead. So the use transition hook provides both the isPending states and the start transition function. So we no longer have to deal or manually set that pending state. So now, when the user submits some input, the transition starts, and isPending is automatically set to true. The data is fetched, after which the transition then starts to update the state based on that returned data. Now, a limitation at the moment is that by default, state updates after an await keyword within start transitions are not marked as transitions by default. So to make this a transition, we do have to wrap it in yet another start transition. This is just a limitation until async context is available, so just something to keep in mind until then. So now, again, if we have a similar situation as we had before, so we first submit Lydia, and then while that submission is ongoing, we change it to Evan, we only see one value rendered to the UI. And this happens because if there are multiple ongoing transitions, React will actually batch them and only commit the changes once all the transitions are done. And in this case, that only results in a single paint, namely Evan. So in React 19, functions that trigger transitions are now called action. So an action is just any function that triggers a transition, which we can do in multiple ways. The first one that we're now familiar with start transition. But we can also create an action using the new useActionState hook. And this is a new hook in React 19 that makes it really easy to use actions and also get these status updates on that transition that this action triggered, and also then set the state based on this return data. So this hook returns an array with 3 values. So first, we have the action state, which is either the data that we pass for the initial state, so null in this case, or it's the data that gets returned by the action once the action completed. Then we have the actual action, which returns that action function that we passed as the first argument. And we can use this value to actually trigger that action or invoke the action to trigger the transition. And lastly, we have the pending state indicator, which is true as soon as the transition starts, and then automatically set to false once the transition has been committed to the DOM. So looking back at the code we had before, even though this was already refactored with the asynchronous transition, we still had to manually set that data. So instead, we can refactor this to use the useActionState hook instead. So we no longer have to have a separate data state, because that is now just returned from the useActionState hook. And the initial state value is now passed as the second argument, which is null in this case. The submit action is the first argument that we pass to the useActionState hook, which by default also receives the current state and the form data arguments. And because we get access to this form data, we also no longer have to manually set the state of the user's input. Instead, we can just directly get this from form data. And we can get the isPending state from the useActionState hook as well. So the behavior we see is the same, just with a lot less boilerplate. So invoking this action triggers a transition, automatically sets isPending to true, and then sets to false once it's been committed. Now, React DOM allows you to work with actions directly through the action prop or the form action prop for buttons and inputs. So the values that we pass to action or the form action prop can be any function, whether synchronous or asynchronous, but they're all considered actions, meaning they all trigger transitions. So this action can either be from the useActionState hook or just a standalone function. And an action automatically receives the form data as a prop, which makes it really easy to work with these form values. And React 19 also introduces a new useFormStatus hook, which makes it even easier to get the status information from the last form submission. So this returns an object which includes the form data that's currently being submitted and also the transition's pending state. So the useFormStatus hook uses the action data from the parent form, similar to how contexts work. So we can use this hook within components that are rendered within forms, and it will just directly access the values of the action. So when the transition is pending, pending is true or returned true by the useFormStatus hook, and once the transition has been committed, this is automatically set to false. So creating reusable form elements is super easy this way, and it's very easy to also provide that real-time feedback and status updates to users. And again, it works pretty similar to context, so just make sure that you don't use this hook directly within the component that actually renders the form. It has to be a child component. Now, an asynchronous task within an action can take a while to actually return some data, or maybe users are on slower internet connections, anything could happen. And instead of showing a pending state, we might want to show the data as if the action has already completed, which we can do if we already know what the return data is going to be. And for this, we can use the new useOptimistic hook. So the function returned from the useOptimistic hook can be used within an action to update the UI before a transition completes. And it receives a state which gets returned initially whenever no action is pending, and also a function that we can then use to actually add that new optimistic state. So the first element of the return array is the current state, which is either the initial state when no action is pending, or it's the returned value from the update function if an action is pending. And the second value is the actual update function, which we can use to actually invoke this function and set a new optimistic value. So for example, let's say that we have some messages that we receive from the server through the messages from server prop. Oops, sorry. No, I have to go back. So in the useOptimistic hook, we set the initial state to be the value of the messages from server prop. So this is the initial value of the first returned element, which in this case is called all messages. So then we map over all messages and then render this, which is just the initial messages from server. Now, when a user submits a message, the add message action is triggered. And inside the add message action, we first invoke the add optimistic message function with the value of the message that we just typed. And this triggers the update function of the useOptimistic hook, which then returns an array containing the current messages from the server along with this new optimistic message. So this now updates the value of all messages because a pending transition is ongoing. And because this now changed value, React will re-render and show the list of messages, including that optimistic message. And maybe to indicate to users that this is still being sent, we can display some sending or pending text, stuff like that. Now we actually send the request, and after some time, the request succeeds, and this updates the messages from server prop. Now, since we use this value as the initial state, all messages now gets this updated value, which again causes a re-render, so now we actually have all the messages. But in the meantime, the user saw the optimistic message. So actions trigger transitions, which are asynchronous by default. But useOptimistic essentially opts out of that asynchronous behavior, so it's immediately reflected in the UI. Now, moving on to some server features, React 19 now also introduces React Server components. So traditionally, we essentially had two ways to render our application. So we could either use client-side rendering, in which case the server-side React tree got rendered to a JavaScript bundle, and then we had some minimal HTML that both got shipped to the client, where then the client-side renderer uses this bundle to rebuild that React tree. Or we could use server-side rendering, in which case the React tree got rendered to both HTML and a JavaScript bundle, still sent to the clients, and then this static HTML was made interactive through that bundle. Now, both approaches rely on the fact that the React renderer needed to rebuild that React tree client-side, even though it already had it on the server. So the introduction of the concurrent renderer in React 18 allowed for a different approach, namely React Server components. So React Server components allow React to send the actual serialized component tree to the client by using a special JSON-like format. And the client-side renderer understands this format and can just rebuild that tree client-side without the need for HTML or JavaScript. So React Server components are never sent to the client, only their return value is in this JSON-like format. So this means that we get to use server-side functionality directly within our components, like accessing databases, the file system, and so on. And this is especially easy because in React 19, we can now use async await to render server components. And the RSC payload remains the same because that's just a representation of what is actually returned. Now, it can happen that this data lookup takes a while to complete. And in that case, the entire React tree needs to wait before it's sent to the client, or before that data is completely fetched before it's sent to the client. So to fix this, we can wrap the server components in a suspense boundary. And this allows React to already stream the parts that were faster to the clients, and in the meantime, render that suspense fallback. Only once the data has been fetched and the RC payload has been generated will this component actually be sent to the client. Now, since React Server components are only rendered on the server and then rendered to JSON without needing any JavaScript, we cannot use client-side functionality by default. And this includes things like hooks, event handlers, windows, and so on. So to render components client-side, we need to explicitly add them to the JavaScript bundle. And to tell bundlers that we want to add them to the bundle, including their imports, we can use the now stable use client bundler directive. And adding this directive adds the components and its imports to the bundle that gets shipped client-side. So React won't render this component on the server. Instead, it takes the CSR, the client-side rendering approach here. So now, because we're actually shipping the component to the client and not just the return value, we cannot fetch data the same way that we could with server components. But there are a couple things we can do here. First, we can just fetch the data within a server component and then pass this data as props to the client component. Or we can use the new use API within a client component and pass the promise as a prop instead of the actual data. So use is a new API, not a hook, that accepts either a promise or a context. And it returns the data of the resolved promise in case we passed a promise, or the value of the context in case we passed a context. So in this case, we're creating the reactions promise within the server components. And instead of awaiting this value, we're just passing the actual promise down to the client. And on the client, we then pass this promise to the use API. So this API automatically integrates with suspense and error boundary. So while we're waiting for that promise to resolve on the client, we can show these suspenses fallback. And then once the promise resolves, the fallback is switched to the actual components. Or in the case the promise rejected, the error boundary gets shown. Now, the benefit of using the use API directly on the client is that the rest of the server components can already be streamed to the clients without having to await that data. So the use API makes it incredibly easy to work with asynchronous data client-side, whereas previously we had to deal with API endpoints and setting loading and error states. React can now handle all of this for us, which really simplifies our code. Now we can also use the use API with context, which essentially replaces the use context hook. So one big difference here, though, is that we can conditionally call it, because it's a hook, or it's an API, it's not a hook. So this means that we can call it after early returns, within conditions, and so on. So the use API gives us a lot more flexibility to use context based on any runtime condition. Now, in our server environment, we can also create a server action. And a server action is a function that runs server-side, but can be called client-side. And really, this is more of a framework feature, because it requires a framework to actually use it. But we can create a server component within a component by using the use server directive. So this can either be on top of a function's body that we then pass as a prop to the client component, or we can create an entire file dedicated to just server actions by adding the use server directive on top of that file, and then import the server action within the client component. Now, it's up to the framework to actually implement this endpoint. But whenever a server action is triggered, React will send the request to the server to execute this function. And we can track the state of this request by getting more information about the action status, for which we can use the use action state hook, use start transition, derive it from the use form status hook, and so on. So server actions make it incredibly easy to work with any server-side functionality within client components, because we no longer have to create those separate API endpoints. And they're especially useful in scenarios whenever we want to offload certain computations or any data manipulations to the server, which really reduces that load on the client. Now, moving on from these server and client features, some other improvements in React 19. So in React 19, we can now access ref as a prop for server components. So previously, to pass a ref to a server component directly, we had to use forward ref. But starting with React 19, function components now accept ref as a regular prop without the need for forward ref. So just this change makes React feel a lot closer to the platform, because we no longer have to import anything from React to actually make this work. And also, ref callbacks now allow a cleanup function. For example, to remove any event listeners, which is really great to prevent any memory leaks. React 19 adds support for rendering document metadata text directly within components. So whenever React renders this component, it will see the title, link, and meta tags, and automatically hoist them to the head of the document. So whereas previously we had to use tools like React Helmet to handle this directly within components, we can now just use it natively in React. But for more custom meta tags, you might still want to use React Helmet. Now, React 19 also adds support for directly using style sheets in the component that actually uses these styles. So we can just directly add them to our components, and React will again hoist these to the head, which ensures that the browser will not render the components until the CSS has loaded. And we can also load a style sheet within a suspense boundary. So in this case, we're loading the button and the comment CSS within the suspense boundary. And since the button CSS has a higher precedence, because that's high, React ensures that this style sheet will be loaded first. And when loading CSS styles in a suspense boundary, React will keep rendering the suspense fallback until the style sheet is inserted into the head and fully loaded. It'll only reveal the content once the CSS is completely loaded. So this prevents that that flash of unstyled content. Now, lastly, staying in the head components, React 19 also includes new APIs within React DOM for working with browser hints. So within our components, we can use APIs like preload, pre-init, prefetch DNS, and many more to use these browser hints. And browser hints can be really useful to fetch or connect to certain resources before they are discovered, which can really help to speed up certain loading times. And React handles the hoisting to the head, but also automatically reorders the browser hints based on their priority to early loading. So as developers, we don't have to worry about the orders performance implications. So this ensures that the most critical resources are made available as quickly as possible. Now, in the next talk, Sam Solikov will show you how to use these new features by refactoring some existing React code with these new APIs. Thank you so much for coming to my talk, and have fun building with React 19.